Howdy! This is your friendly neighborhood physics teacher here, and this week we're going to talk about lenses. So last week was about mirrors, so it reflected. Now we're going to talk about lenses, and they refract. If you remember, what refraction is when light changes medium and it slows down. So anytime it changes medium and it slows or speeds up, I guess it could, or it changes the light changes velocity. So going from, in this case, it's going from a gaseous state to a solid state. So it's going to slow down. And then from so we're going to say gas here. This is a solid. And then going from a solid back to a gas, it's going to speed up. And then going from a gas to a solid, slow down, and then do the exact same thing. So anytime it changes mediums, there is a change in velocity. That's just on the wrong side of the thing. There we go. Okay. So concave lenses still have that concave. It looks like you can stick your hand into a cave. Still have that look. And they pretty much, they make your lines diverge. And you saw that with the mirror when it sat there and reflect and they converged the focal point and it diverged on the virtual side. Now, another thing lenses do is your virtual and your real flip. Now, erect or upright and inverted are still the same, but your virtual and your real side flip. Because think about it. If you're looking through a lens, and your lens would be like glasses, and it could even be sunglasses for the ones that don't wear glasses, you're looking through that lens. Since you are looking through that lens, your real side is in front of you, because that's what you're seeing. The virtual side would be between the lens and your eyeball. Would be between the lens and your eyeball. Ooh, excuse me. So that is why the virtual and real side flip for lenses. It's one thing to pay attention to. Your virtual side and flip for lenses. Now, instructions again are extremely similar. So from the top of the object, you draw a straight line parallel to the optic axis. That's your equilibrium line. And then from the lens where you stopped, you're going to draw a diagonal line through the focal point. That sounds extremely familiar, just like the mirrors. Let's see if the next one. Draw from top, diagonal line, making sure you cross the optic axis, drawing on both sides of the lens, and then where the reflection ray for 2 and 3 cross, that's where your image is drawn. Now, step 1 and 2, exactly the same. It's step 3 that changes. So let's kind of see how that looks. So step 1, you're coming straight. Now, most of the time you see how, because it went from lines are going straight and then it changing, it's slowing down as it goes through the lens and then speeding back up. You don't have to sit here and figure out, because I can make you mathematically figure out how much it's going to change and stuff. We don't do this part in the middle. Usually you draw the line until it's straight, and then you decide how much to angle by using the focal point. So that's the extra step. It's not necessarily needed. And you're able to, because all those lines, or the angle is figured out by the focal point. And again, we just ignore the thickness of the lens. So it looks more like that. And again, all those lines line up with the focal point. So it just makes drawing it a little bit easier, since drawing it can be confusing to begin with. So you're going to do a straight line, hitting that, hitting the middle part of the lens, it being parallel to the optic axis. Remember, that's just your equilibrium line. And then you're going to hit a diagonal line that goes out. Now, if you notice, the real side again makes the solid line, but you still want to see if your image could be virtual. So don't forget that dotted line, and it crosses your focal point. So you just use your focal point to figure out what angle to draw that in. Now your second ray just goes through the middle. Just all it does is go straight through the middle. And where your two lines meet is where your image is. If you notice, light rays don't converge, but sight lines do. So all that's saying that you don't have this dotted line here for your second choice. And that is where your image would be. So your image is virtual and upright. Thinking about a lens, a concave lens, would you be able to see that image? Hopefully you said no. Because think about it, we use lenses to look through. So anything on the real side you'd be able to see. Anything on the virtual side you would not. Okay, so let's start. So object. You draw a straight line, then diagonal using the focal point, and then a straight diagonal line. Your image would be here. The key thing is, if your lenses are working truly, your image and your object would line up perfectly. Your image and your object would line up perfectly. That means your lenses are doing what it needs to do. So convex. Convex, again, you get that curve aspect of your lens. So they make all the rays converge. So if you have a virtual image, so you're going to do a straight line, hit, and then a diagonal line through the focal point. Not forgetting your dotted lines out. Your next one, just a straight line. Don't forget to go this way also. You have to continue. And so your image would end up being, oh, there we go. So your image would end up being there. There you go. Where your sight lines converge. Okay, so your turn. So we're going to draw a straight line, which I just did, and then a diagonal line. Now what this didn't do, so you didn't do your diagonal line, your dotted lines this way, your sight lines. You didn't do a sight line, but your image converged on the real side and upside down. That's about it for lenses. So we have notes today for Monday. You'll have some conceptual questions over lenses on Tuesday. You'll have a FET on Wednesday. You'll have calculations on Thursday. And then Friday will be a recap. Hope you have a wonderful week. Remember, you're loved and appreciated. Bye.